Hi guys, welcome to another episode of MrLopezClasses.com. In this episode, we are going to talk about the fuel injection common rail systems, and we are going to check the troubleshoot of the fuel systems, the different type of problems, the solution, and the OBD2 codes related with each problem. Okay, my friends, in this particular case, I am going to explain the common rail fuel injection system. If you remember in the previous episode, I explained the different type of pumps. Basically are mechanical fuel injection pumps or electronic fuel injection pumps. The mechanical fuel injection pump should be timed according with the timing of the position of the camshaft and crankshaft. For mechanical fuel injection pump is mandatory, is necessary. If the fuel injection pump is electronic, you can install the fuel injection pump at any position of the cam and the crank. It's not necessary align the timing because the electronic fuel injection pump supply constant power to the common rail. The common rail is powered from the pump, the electronic pump, and the common rail have pressure all the time. For that reason, it's very important the pressure regulator on the fuel injection pump. This is an schematic about the common rail fuel injection system, electronic. We are going to refresh quickly the process. We have the fuel tank. The fuel tank have the supply line and the return line. All right. The supply line have the transfer pump. The transfer pump can be located here, or here, or here. Doesn't matter. Okay. Remember that we have an electrical transfer pump, 12 volts or 24 volts, and we have the manual priming pump or lifting pump. Okay. We have the transfer pump. The power is coming from the ignition switch or is coming from the computer, the ECM in the computer. Right now, we are going to check a typical wiring diagram in a common rail system, and we are going to check where are coming those wires. Okay, this is one of the wires coming from the computer, the ECM. After that, we have the primary filters or water separator filters with the gauge in between both of them. Remember that gauge read negative pressure, vacuum pressure, suction. According with the amount of negative pressure on those on the gauge, you can identify if the problem is on the filters or if the problem is because the filters are open, no filters. This is very important. I explained in a previous episode how to read the pressure on the pressure gauge located in between both filters. In some cases, if you only have one filter, you have the pressure gauge on the handle, on top. After that, we have the secondary filter. The secondary filter, normally the secondary filter is bolted on the block of the engine, is part of the engine. The secondary filter in some cases is a tandem, two filters, and the secondary filter have a bracket where you can bleed the system and where you can prime the system. In some cases, the priming pump is integrated with the bracket. And this is the priming pump in order to bleed the system. You remember, in order to drain the air, in order to drain the amount of bubbles in the system. And this is the input of the fuel injection pump. The fuel injection pump receives the power from the computer, and the computer additionally supply power for the injectors. The computer supply power for the fuel injection pump, for injectors, and for transfer pump. All of those elements receive the power from the computer. Right now, we are going to check the wiring diagram, and we are going to verify how is the procedure to follow those wires. For that reason, it's important, it's critical, it's mandatory that you check all the time the service manual and verify in the service manual if you have the wiring diagram for fuel system. If you have the wiring for each element. Right now, we are going to check each by each. All right, this is the situation, and the fuel, this is the input of the fuel injection pump, and this is the output. The output enter in the pressure, in the high pressure manifold, and that manifold have a pressure regulator. And normally in the other end, that manifold, in some cases, the manifold have located here, a pressure gauge. The pressure gauge is located over there in order to read the pressure of the system. This is important. I recommend if the common rail doesn't have the pressure gauge, install the additional pressure gauge. is important. If you are the engineer of a big boat, a mega yacht, you enter in the engine room, you check the water separator filter, you verify if the fluid is passing. You can identify if you don't have bubbles on the system. You can identify if you don't have water sediments, and additionally you check on the common rail of each engine and you verify the pressure according with the manufacturer specification, according with the recommendation of the manufacturer in this particular service manual. All right, this is the system. This is the common rail system, and what is the most important part in this system? Verify that the pressure in the common rail is the appropriate pressure. Verify the condition of the primary filters. No water, no foam, and the quality of the fuel. The fuel is clean. Verify that you don't have leaks, and that's it. This is the secret of the common rail system. The secret is the pressure of the fuel at the input of the common rail. The pressure should be according with the pressure recommended by the manufacturer. Okay, we are going to check quickly the pump. The pump normally have a small computer. The name of that computer is FSD. The name of that computer. That computer is talking all the time with the main computer of the engine, the ECM. The ECM sends the signal to that computer and also send the signal to the stop solenoid. You remember the solenoid that we have on the screen right now? Exactly. This is that solenoid. This is the solenoid that allows that the fuel enter in the fuel injection pump or block. In other words, that solenoid is used to stop. All right. For that reason, the majority of the manufacturer they call fuel shut-off solenoid valve. Fuel shut-off solenoid valve. Okay. This valve, the shut-off valve, and the FSD. Both of them receive the signal from the ECM, the main computer of the system. The main computer is connected to the harness. All right. Okay. This is the typical. This is the input, and this is the output per each injector. This is a wonderful pump, constant pressure, and this line, one of these line is for input of fuel, and the other one for return. Input and return. How many returns I have in a typical diesel engine high pressure system common rail? I have one return on the fuel injection pump. I have other return on the injectors. Yeah. And I have other return in the manifold. The high pressure manifold, the supply manifold have one return. If the pressure is superior to the limit recommended, the fuel, the regulator return into the tank. I have three returns. One return on the injectors, other return on the rail, and other return on the pump. Right now I have another picture to check that one. Okay, this is the situation. We have the computer, we have the common rail, this is the pressure sensor, and normally here you can install the gauge. You can install the gauge over there. You can install the gauge here. Over there you have the gauge, the pressure gauge. All right. This is the tank. This is the pump. The pump suction the fuel, send the fuel with high pressure into the common rail, and the common rail at the end have the return, and the return into the tank. The injectors, each injector have input here from the common rail and return over there. Input from the common rail and return exactly per each injector. And each injector receives the power from the computer, power from the computer, power from the computer, power from the computer, and also the computer have input and output signals coming from the sensors. There are a lot of sensors speaking when the computer in order to control the fuel. Can you tell me a couple of sensors that work together with the fuel systems? Yeah, the throttle position sensor, one. Other one, oxygen sensor, important. Other manifold absolute pressure sensor, MAP sensor. Other MAF sensor, manifold absolute flow sensor. Other one, IAT sensor, the the temperature of the air entering in the combustion chamber. Very important. Those sensors and the coolant temperature sensor, that's very, very important. Those sensors work together with this computer in order to calibrate the system. Simple. Simple. All right, my friends. Yeah, this is the typical fuel injection pump. That connector is coming from this is the small computer FSD, and the big computer ECM or PCM enter here and is connected. And this is the signal for the chewed off valve. Okay, and yeah, this is basically the elements: the fuel injection pump, the injectors, and the common rail. Remember, 3 returns we have over there. Yeah, this is one input is for the input of the fuel, and the other one is the return. That's the typical fuel injection pump, common rail. My friends, remember, this pump is mechanically connected with the gear of the crankshaft and the gear of the camshaft. This is electromechanical. There are other pumps in fuel injection pump, common rail, completely electronic, completely electric pump. The pump is powered from the computer directly. That pump is not connected with the gear of the crank and the gear of the cam. That power, 24 volts or 12 volts, is coming directly from the computer. Okay? And the one is the input of the fuel, and this is the return of the fuel. And this is the solenoid. This is the solenoid, the chewed off valve. The solenoid valve, this is the power for the motor of the pump. This is a vane pump, rotary vane pump. And this is the input of the fuel, and this is the return. Completely electronic. And this one is electromechanical. Okay, because the input, the rotation is mechanical. The gear is connected with the gear of the crank and the gear of the cam. However, the computer receives the signal from the computer to calibrate the timing, and to calibrate the pressure. Important. What is the function of the FSD computer in the fuel injection pump? The function of that small computer is control the timing, control the pressure of the fluid coming out, and control the load. Of course, the RPMs. Load, RPMs, amount of pressure, and the timing. Very important, the function of that computer. Timing, pressure, load, and RPMs. All right. Okay, and this is the system. We have the common rail. This is the pump. This is electromechanical because the input is mechanical, connected with the gear of the crank and the gear of the cam. However, the FSD computer receives the signal from the ECM or PCM. Both computers are connected, and the solenoid valve here receives the power also from the computer. Okay, this electromechanical pump, the input is mechanical, gear with gear, and the signals are one big signal coming from the ECM and the other small signal coming from the ECM to control the chewed off valve. Okay, and the high pressure and the low pressure. This is the low pressure fuel coming in, that the input coming from, this is the secondary filter that the fuel enter over there, and the fuel in the out is going with high pressure, enter in the common rail at high pressure, and from the common rail enter in each injector. This is the input per each injector, and on top is the return. That's the input per each injector, and on top is the return. And additionally, each injector receives an electric signal in between 4.5 and 5.0 volts coming from the ECM. Right now we are going to check the wiring diagram. Yeah, that's the signal coming from the ECM. That's the signal coming from the ECM. All right. Exactly. The common rail, the injectors, the fuel injection pump, and the computer. This is the pressure regulator. This is the pressure regulator. That's the plug for the pressure regulator at the manifold. Very important. And this is the return. Okay? Okay, this is the wiring diagram. This is a typical schematic where you founded that wiring diagram, that schematic. Yes, in the service manual. In the service manual of that particular engine, you founded that schematic. My friend, in my opinion, this is the Bible. If you have the schematic, you can do the diagnosis easily. Don't try to do the diagnosis in any type of diesel engine if you don't have the wiring schematic of the fuel system. This is the wiring schematic of the engine. Let me check one per one. One per one. This is the plug on the computer. The computer that you have on the screen. Exactly. That computer, they have that plug. And this is the harness. The harness enter over there. Those are the pins. Those are the pins that we are going to check according with the socket on the computer. Yes, of course. For example, those are the injectors. Oh, the injectors. One pin is negative. Normally, all the sockets, they have one group of pins dedicated for ground. Look at this. Those pins, the pins 33, 49, 53, 51, 27. Those are negative pins. Those are connected to the negative of the battery, the negative DC bus bar. Okay, for example, for injector number one, one pin is connected with ground, and the other pin, the pin number 2, is the power for the injector. Oh, I have problem in the injector number 2 of my engine. Let me check with my multimeter carefully. When I open the ignition switch, if I have in that pin, in the pin number 2, in between 4.5 volts and 5 volts. Oh, I have 4.7. Okay, I have voltage coming out from the computer. Let me check on top of the injector. On top of the injector, if I have 4.5. No, I don't have nothing. Okay, the cable is interrupted in between this point, in between the socket of the computer and the injector. I need follow the cable or replace that cable. Alright, the same with the injector number 2 or 3. Oh, this is the potentiometer. That potentiometer, the potentiometer to accelerate, increase or decrease the RPMs. That potentiometer is connected with the console, with the control at the console. That potentiometer have two signals. One signal for idle, other signal for Y open throttle, the pin 15, the pin 60A, and the ground is the pin 22. Too simple. I have problem with my potentiometer. Yeah, those are the pins related with the potentiometer. Oh, look at the MAP sensor, manifold absolute pressure sensor. That's critical. That sensor send the signal to the computer and receive signal from the computer in order to control RPMs, in order to control the wastegate on the turbocharger. In the next episode, I am going to explain the turbocharger. Yes, that's the MAP sensor. And the pins are one pin ground, other pin signal, the pin 71, and other pin constant power coming from the computer, 12 volts, coming from the pin 44. Marvelous. Yeah. And the other one, the pressure regulator at the common rail. Yeah, the pressure regulator. The pressure regulator, the signal is coming from the pin number 74. This is the coolant temperature sensor. Coolant temperature sensor, this is the ground, this is the signal. The signal is in the pin 46. If I have a code related with temperature, coolant temperature, the sensor is located in the pin 46. And what about, oh look, this is the RPM sensor or crankshaft sensor. The crankshaft sensor have the signal in the pin 41 and the ground in the pin 14. And I can follow all the signals. The tachometer, look at the tachometer. Yeah, look at the other sensor. What sensor is that? That engine have two coolant temperature sensors. This is the fan. This is the fan. If the engine is in a truck, the fan of the radiator. This is the tensioner for the timing. This is the power. Look, the power for the shut-off valve is the ground is in the pin 15, and the positive. The positive is coming from ignition switch. This is ignition switch. Yeah, you remember? I explained to yours. The shut-off valve is controlled by the ignition switch. the ignition switch control the transfer pump and control the shut-off valve in order to allow that the fuel enter in the fuel injection pump. Perfect. But the computer is coming from other signal. And the ground is here. Yeah, I have all the information related with the fuel system of my engine. This is the procedure to read the wiring diagram according with my engine. Of course, guys, in some cases, the pins of the computer are too close, and it's difficult connect the plug of the harness. For that reason, I recommend that you prepare cables like this in order to connect the plug on the computer or the plug on the harness and connect your multimeter. Be careful, you need avoid touch two consecutive pins because you can make a short and you can destroy the computer. And you ruin the system. The most expensive part in this system is the computer. This is the critical part, and this is the part that you need to protect all the time. Alright? Be careful with those pins. Prepare the cables, prepare the terminals in order to connect your multimeter. And this is the diagram. If you have access to the diagram, you can solve any type of problem. Let me explain something about the fuel system. In a fuel system, in order to do the troubleshoot, the problems are related with the low pressure pump or transfer pump, or the problem is related with the computer, the ECM, or the problem is related with the harness, or the problem is related with the pressure of the fluid entering into the common rail, or the problem is on the air filter. Those are 99% of the sources of problems. Once again, is the air filter, pressure on the fuel transfer pump, low pressure pump, power on the fuel injection pump, power on the computer or on the solenoid shut-off valve, and pressure on the common rail. For that reason, you need frequently check pressure on the pressure regulator located on the common rail. Okay, my friends, right now we are ready to understand what happened with the fuel system, and we are going to analyze those fuel systems. Before we analyze the troubleshoot on those systems, I want to read that picture. That picture is of a typical diesel engine with a turbocharger. If you check, this is the exhaust manifold. The exhaust manifold goes into the hot area of a hot section of the turbocharger, spin the turbocharger, and the other impeller in the other side suction the air from the air filter. The air filter is located here, and the air at high pressure pass through the intercooler in order to reduce the temperature of the air. The air continue. We have the air intake air temperature sensor here, and the air continue and enter in the combustion chamber with the appropriate pressure and temperature. Alright, and the fuel. We have the fuel tank, we have the transfer pump. The transfer pump bring the fuel, and the fuel enter in the fuel injection pump. The fuel injection pump increase the pressure of the fuel at high pressure. The fuel enter with high pressure in the common rail, and from the common rail the fuel enter in each injector. Each injector have input in one side and return into the other side. This is one of the returns. Other return is coming, look, one return from the injector, other return from the injection pump, and other return from the common rail. We have three returns. One return, yellow one, from the common rail, other return from the pump, and other return from the injectors. All of them converge in one point and return into the fuel tank. And this is the picture, and here you install a pressure gauge. You can install one pressure gauge in the low pressure side, and you can install another pressure gauge here in the high pressure side. This is the typical schematic in a turbocharged diesel engine. Okay, my friends, and we are going to check quickly the troubleshoot for common rail fuel injection system. The typical problems related with that system. Okay, the first problem is problems in idle. Problems in idle. First possibility, okay, the tank, the fuel tank is empty or the vent is black. Yeah, this is possible. What is the solution? Fill the tank, bleed the system, and check the vent, of course. The second one, air in the fuel system. Bubbles, foam. Air in the fuel system. What is the procedure? What is the first step when you have air in the fuel system? Check in the water separator filters if you have air in the fuel passing through the filters. If you have air over there, you remember what is the procedure? You open the cap, like the video that you have over there. You open the cap a little, you drain, you spill fuel with bubbles, and you tie the cap again. Bleed the fuel system and eliminate the air. And after that, when you eliminate the bubbles on the record Parker, you can bleed the system. You can bleed the system exactly like the video that you have over there in the secondary filter. All right, perfect. Or you can bleed the system at the input of the fuel injection pump. In that valve, you can bleed the system again. All right. Other possibility is the bracket is loose. The bracket of the pump, replace if it's necessary. Overflow feeding interchange with the inlet feeding, in some cases the people confuse the supply feeding with the return feeding and switch those feeding. This is very common. Other is cold start device malfunction. What is the meaning of a cold start? The glove plugs in some cases. In some cases the glove plugs are the problem because the temperature in the combustion chamber is not appropriate and the engine start improperly. Okay, in that case, check the cold start mechanisms. Other one is the fuel injection pump is defective. Replace the fuel injection pump. How can you know if the fuel injection pump is defective? The gauge on the manifold, the common rail manifold, showed a pressure below the limit. Probably you need to remove the fuel injection pump, send the fuel injection pump to the laboratory in order to calibrate the pressure. You remember the ball with the wire, the safety wire? That's the ball to calibrate the pressure. Don't try to touch that ball. Send to the machine shop and they calibrate for you. Never try to adjust the pressure by yourself. Alright, this is the typical other one. Roach idle when the engine is warm. It's a common situation. In this particular case, the fuel is contaminated. Probably you have water on the fuel. Probably you have a dirty fuel. The fuel is not good. Okay, you need to verify the quality. Drain the tank, flush the system with proper fuel. Other possibility is air in the system. Bleed the system again. Other possibility is the pump is loose. The nozzle on the injection system, the nozzle on the injectors are defective. You need to remove the injectors. Check the injectors. If the injectors are mechanical injectors with the pump, verify the pattern, verify the flow, or send the injector to the machine shop. With the magnifier, you can verify the quality of the nozzles and verify if the nozzles are in good quality. Alright, the sequence, the firing order is modified. This is not common because you remember that the high pressure lines are rigid in a special stainless steel, and it's impossible to bend those lines. But okay, low compression, that's very common. You remember in a specific, in this case, in diesel engines, what happens if you have low compression in one cylinder? Yes, if the compression in one cylinder is low, below the limit, the temperature and the pressure is not appropriate. When the fuel enters over there, the fuel never ignites, and the fuel goes out pure fuel. Low compression, very important. What is the procedure? Check the compression. Fuel injection pump defective, replace the fuel injection pump. Once again, the same situation. Low power, that's very common. Alright, the fuel is not appropriate, the tank is empty, the fuel filter is black, the injection lines are black, the fuel supply is black, loose connections, leaks on the system, the timing is incorrect, the nozzles are damaged, the filter is blocked, the sequence of the injection is not the appropriate sequence, the Y open throttle is not adjusted, overflow feedings interchange with the inlet feedings, low compression, fuel injection pump defective. The possibilities are the same all the time. Those are the possibilities, no more. Other is excessive fuel consumption. Okay, before we read the table, excessive fuel consumption. What is the most common cause for that situation? Excessive fuel consumption. Yes, the air filter is clogged. Or a couple of injectors open excessive. Too much or stay open all the time because the injectors are broken. Yes, the timing is incorrect. This is not common, but it's possible. The nozzle is defective, and spray fuel constantly. The engine air filter is blocked, of course. The sequence of the injection is not appropriate. The idle is not adjusted, probably, and the acceleration is too high in idle. The glove plugs are, and the fuel injection pump is defective. Once again, the possibilities repeat in each situation. In each situation, you have the same possibilities. White or blue smoke. White or blue smoke. Pay attention. If I have a little white smoke, it's because water entered in the fuel tank. Water entered in the fuel tank. What type of water? Fresh water. If salt water enter in the fuel tank, immediately the salt water enter in the combustion chamber, the piston expand because the expansion of the aluminum is double than the expansion of the steel. Alright? No, it's fresh water. Okay, if fresh water enter in the tank, you have problem. How the fresh water can enter in the tank? You remember, if the tank, the installation of the tank in the surface, the tank is below the deck. If the deck have a leak of water and the water is accumulated on the top, on the surface of the tank, and the water enter through the gasket of the flow switch, the water penetrate the tank. Or if the tank is corroded, pitting corrosion, the water, the moisture enter in the tank and it mixes with the water, right? Fresh water. And this is one of the possibilities for white smoke. Water entering in the combustion chamber. Other possibility is because somebody cleaned the engine room of the boat with water at high pressure and not protect the air filters properly, and right now the air filters are clogged with fresh water. When the engine starts, suction water and that water enter in the combustion chamber. Yeah, this is another possibility. Okay, blue smoke. Blue smoke is problems on the valves on the head or problems on the turbo. Right now we are going to talk in the next chapter about the turbo. In the cold side of the turbo, the seal is damaged and the oil pass and enter in the combustion chamber. Right now we are going to talk about that. It's problems on the turbo or problems on the valves. Or, of course, if all the piston rings are broken, the oil penetrates. Normally, in normal conditions, the oil never penetrates through the piston rings because the bottom piston ring oil controller return the oil into the oil pan. You remember in that chapter 8 about the lubrication system? Alright. Okay, possibilities for white or blue smoke. Improper gasoline, the tank is empty, air in the system, fuel filter block, injection lines block. Exactly the same possibilities plus the additional possibilities that I gave to you right now. Right? You need, once again, in this moment, you are pretty close to be a doctor in diesel engines. You can close your eyes, ask questions, and you can solve it all the situation by phone. Of course, when you visit the boat, it's because you have the solution. You go directly where the problem is focused. Alright, black smoke. Black smoke, once again, the air filter is blocked, and proper fuel. Those are the possibilities for black smoke. Of course, additionally for black smoke, we are going to add other possibility. The oxygen sensor is reading improperly because the oxygen sensor is contaminated, is clogged, and send an erratic information to the computer. No? And another possibility is that the map sensor, vacuum sensor, is working improperly. You need to verify the map sensor. Please check the video clip related with the OBD2 code. How to read OBD2 codes. This is a wonderful video, and I explain code by code the possibilities, the solution, and the code. Alright, my friends. And the engine never reached the wide open throttle. Once again, improper gasoline tank, empty air filter, and throttle position sensor working improperly, coolant temperature sensor working improperly, oxygen sensor working improperly, map sensor working improperly, air intake temperature sensor working improperly, MAF sensor, manifold absolute flow sensor working improperly. Those sensors produce erratic information, and the engine never reached the maximum RPMs. Yeah, those are the typical problems related with fuel system, and you need to be familiarized with those problems and with the solution. For that reason, it's important the question to the captain, the question to the customer. What about the temperature in idle? What about the temperature in wide open throttle? What about the RPMs in idle? The RPMs in What about the pressure on the pressure common rail? Perfect. What about the pressure on the filters in the secondary filter? Low pressure side. Oh, perfect. What about the bubbles on the record Parker filter? No bubbles? Perfect. You have water in the water separator filter? No, I don't have. Okay. Those questions are critical in order to identify other important questions. What about the temperature in the exhaust manifold? Remember in the elbow where the water is mixed with the smoke? In that point you need to check the temperature in that elbow. It's critical. This is another important question. That's it, my friends. This is the procedure to solve problems related with fuel. It's not complicated. The only that you need is isolate the problem, identify if the problem is in the low pressure side or if the problem is in the high pressure side. If the problem is in the low pressure side, we are going to be concentrated on the primary and secondary filters, and we are going to be concentrated in the power for the low pressure pump and in the priming pump. That's it. If the problem is in the high pressure side, we are going to be concentrated in the pressure on the gauge, on the manifold, and we are going to be concentrated in the pressure regulator located at the end of the common rail, and we are going to check if the injectors receive the signal in between 4.5 volts and 5 volts in each injector. Always checking, always checking the diagram. Checking this diagram. This diagram is critical. This is the diagram that we are going to follow in each scenario. If you have the diagram, it's pretty simple, because if you have the plugs and you have the wires appropriated, you can check what is the pin. I am going to open the ignition switch and check if I have power in that pin. I have power in that pin. After that, I am going to check in the harness in between the pin and the sensor. I am going to check continuity between the middle pin and the pin 17. Okay, I have continuity. Beep. No beep. And the harness is good, the harness is not good. My friend, I hope you enjoyed this video. I hope you enjoyed this chapter. And we are going to complement this chapter with the episode related with the OBD2 codes and DTC codes. Thank you.